Flash memory. The flash memory cell consists of one transistor with a floating gate whose threshold voltage can be changed programmed repeatedly by applying an electrical field to its gate. The memory cell transistor can have two threshold voltages, two states corresponding to the existence of charges, electrons at the floating gate. When electrons are accumulated at the floating gate, the threshold voltage of the memory cell becomes higher and the memory cell is considered to be in a one state as a convention. This is because the memory cell is not turned on when the read signal voltage, that is 5 volt, applied to the control gate and the baseline precharge level, that is VDD, is maintained. The threshold voltage of the memory cell can be lowered by removing electrons from the floating gate and the memory cell is regarded to be in a zero state. In this case, the cell transistor is turned on with the applied voltage and the bit line is discharged to ground. Therefore, the cell data of flash memory is programmed by either storing or ejecting electrons in the floating gate of a MOS transistor through channel hot electron injection or Flower-Nordum tunneling mechanism. The schematics cross section of views of the flash memory cell for two programming mechanisms are shown in figure A and B respectively. When high voltage, example 12 volts, is applied to the control gate and across the drain to source, that is example 6 volts, electrons are heated by high lateral electric field. Avalanche breakdown occurs at the near of the drain and electron hole pairs are generated by the compact ionization. The high voltage on the control gates attracts and injects electrons into the floating gate through the oxide and holes flow to the substrate as the substrate current. Instead of using hot electrons, the floating gate is programmed or erased by the tunneling current of the oxide by the high field of greater than 10 megavolt per centimeter. When the 0 volt and a high voltage, example 12 volts, are applied to the control stage and the source, electrons at the floating gate are ejected to the source by tunneling effect. Figure shows equivalent capacitive coupling circuit of a flash memory cell when the voltages CG and VD are applied to the control gate and the drain. The voltage and the voltage at the floating gate FG our capacitive coupling is expressed as V Fg equal to QFG by C total plus CFG by C total plus CFD by C total FD. C total equal to CFC plus CFS plus CFB plus CFD, where QFG is charge stored at the floating gate, C total, the total capacitance, CFC, the capacitance between floating and control gates, CFS, CFB and CFD are the here you can see in this figure and data programming and erasing methods in the flash memory. A. Hot electron injection mechanism. B. Flower Northam tunneling mechanism. Capacitance between floating gate and the source bulk and the drain bulk. Capacitances between the floating gate and the source bulk and drain VCG and VD are the voltages at the control gate and the drain respectively. The minimum control gate voltage VCG required to turn on the control gate transistor can be obtained by substituting Fg into Fg and arranging equation as follows. Vt Cg equal to C total by CFC Vt Gf minus QFG by CFC minus CFD by CFC Vd, where Vt Fg is threshold voltage to turn on the floating gate transistor. Here you can see the figure equivalent capacitive coupling circuit of a flash memory cell. Here you can see the figure IV characteristic curves of the flash memory cells with low and high threshold voltages for the threshold gate voltage. Also the difference of threshold voltages between two memory data states 0 and 1 can be expressed as delta VTCG equal to minus delta QFG by CFC. Figure shows the IV characteristic curves of the flash memory cell for the different threshold voltages. A control gate voltage VR is said to be large enough to turn on the low VT transistor but insufficient to turn on the high VT transistor for the cell read operation. Various types of the flash memory cell structures and array. Architectures for the logical connections of cells using different programming mechanisms have been proposed. NOR, NAND, and DNOR, divided bit line NOR, high CR, high capacitive coupling ratio cell, 3D and multi-level cells are some examples of flash memory cells. In this session, the cell organization and the basic operations of most popular cell structures NOR and NAND are explained followed by the multi-level cell concept. Thank you.